Hello everyone, this is Jingyu. What is superstring theory? Have you heard about that? Well, we know that the quantum field theory treats the particle as ripples in fields. Similarly, string theory treats the string as ripples in string fields. Theorists use strings to describe the composition of our universe, and the size of the string, which is 10 to the negative 33 meters, 2,000 times smaller than the size of the quark. Can you believe that? And different vibration modes of the string correspond to different types of elementary particles. Superstring theory is an enhanced version of string theory, as they are both a set of equations and theorems describing the quantum mechanical behavior of strings. The difference between them is just that string theory only describes the particles like bosons, which have a spin of 0, 1, 2, 3, and the superstring theory describes both bosons and fermions. Fermions are particles which have spin of one half, 2/3, etc. From my perspective, after reading the introductory of the superstring theory, there are some difficulties and challenges that theorists are facing to explain themselves. I'll list two of them here. First, the superstring theory implies a total 10 space-time dimension. Although it's kind of okay to explain as our 3D world has the three large dimensions plus a time dimension, the extra 6 dimensions are somehow hidden dimensions. As scientists always explain this to the layman, how the hidden dimensions are just like the ant walking on the 3D wire, but as if person seeing it from far away, it looks like the ant is walking on the 2D line, as this left picture shows you. But in the physical science, we want to find as much evidence as possible from the experimental results, right? So the extra dimensions are in a short distance, even smaller than the size of the quark. So that's really hard for us to detect with current experiments. Therefore, it's difficult to say whether the superstring theory is completely true or not. Second difficulty is that how to make superstring theory be consistent with quantum field theory and quantum gravity even. As we learned from the pre-class reading, quantum field theory is the theory of particles that combine with the ideas of Einstein's general relativity. How to use the complicated math in the string theory to describe or somehow connect with the quantum field theory is a challenge for physicists, as is quantum gravity. So here's a picture show is a representation for quantizing gravity on the right hand side here. So how about my opinion? Well, I first heard about string theory back to my middle school age from the scientific magazines, books, and documentaries. Back then, I truly believed that this is a real thing. Right now, even though I understand it has many challenges to become a more convincing theory, I still think describing the universe as the level of strings and brains is probably more subtle and advanced than describing the universe as compositions of particles. I think it's still helpful to develop superstring theory first mathematically or theoretically and let it make sense in its own theory. Later on, if we have more development on the experimental aspects, we can try to add them, we can try to design some experiments to test the possibility of superstring theory. I believe we shouldn't get rid of the superstring theory just because it's not completely makes sense or at this point it's not testable. People have spent decades working on superstring theory for a reason. I think it's still an appealing explanation for our universe as for now. Thank you so much.